last lecture, we started the chapter alcohol, phenols, and ethers. In this chapter, we completed the nomenclature system of alcohol, phenols, and ethers and started the methods of preparation of alcohols. So these two methods already completed, but just I want to do the revision of these two methods because many times this is asked for board exam. The first one is from alkyl halide by hydrolysis with aqueous alkali and moist silver oxide. These both the reactions are already completed in the chapter number 10, halogen derivatives. See, these two reactions are same in this. These are nucleophilic substitution reactions in which nucleophile is OH minus. This is a famous SN2 reaction. SN2 reaction is substitution nucleophilic bimolecular in which primary alkyl halide is prepared and the nucleophile is OH minus, iodine is replaced and we get the methyl alcohol. The second reaction is also same by using AgOH, that is silver hydroxide. It is doesn't exist, but it is prepared in situ by using moist Ag2O. Moist Ag2O, it is a silver oxide when in a aqueous condition, it acts as AgOH and in AgOH, OH minus is nucleophile. It attacks, bromine is replaced and we get the ethyl alcohol. These two reactions already explained yesterday. Now, this reaction is also explained yesterday that this is also completed in 11th standard. This reaction is catalyzed by concentrated H2SO4 and we get ethanol. This reaction takes place according to the Markovnikov's rule. Yes, now this is hydroboration reaction. For the NEET JEE exam, this is asked. Hydroboration means addition of diborane. Diborane is nothing but B2H6. See, it is written here B2H6. Directly, I am coming to the example. In this tetrahydrofuran, THF, it is used as a solvent. Solvent doesn't take part in the reaction. It only acts as a solvent for refluxing the reaction solution. So this is a B2H6. See clearly here. See carefully. B2H6 is for the understanding purpose. It is written HBH2 twice. It is nothing but B2H6. The reaction takes place according to the anti-Markovnikov's rule. So in anti-Markovnikov's rule, the negative part, this is BH2 is negative and H is positive. This part is attached to the carbon atom, which contains less number of hydrogens. See in the product here. This hydrogen is attached to the carbon atom, which contains less number of hydrogens, and see the negative part. Negative part is attached to the carbon atom, which contains more number of hydrogens. So note one thing, the hydroboration reaction takes place according to the anti-Markovnikov's rule, and one important thing is only the primary alcohols are prepared by this method. We can't prepare secondary and tertiary alcohols. See, first one, B2H6, this is hydrogen is added here and BH2 is added. Again, the second molecule of alkene is added. We get CH3, CH2 twice, BH. And if the third molecule is added, we get CH3, CH2, CH2 thrice, boron. Means trialkyl borane is formed here. See, the name of this product is trialkyl bromine. It is tripropyl bromine actually, which is on oxidation with hydrogen peroxide, H2O2. H2O2, it is hydrogen peroxide in alkaline medium, OH minus is alkaline medium. We get the primary alcohols here, propane 1-ol. So this is one of the method of preparation of alcohols. Now the fourth method is by reduction of carbonyl compounds. Now carbonyl compounds means these compounds contain carbonyl group, CO group. Prajwal Ubhe, if you have any doubt, I will clear after the lecture. Don't raise your hand in the lecture. So aldehydes here, aldehyde, ketones, carboxylic acids, esters, these are the compounds called as carbonyl compounds. Carbonyl compounds means they contain CO groups here. See, CO, C double bond O. Aldehyde contains COH functional group. Then ketone contains R, COR. So by reduction of aldehydes and ketones, we get alcohols also. Reduction, these are the reducing agent. These are very famous reducing agent. H2, nickel or H2PD, lithium aluminum hydride or sodium bromohydride, NaBH4 we can use. These are the reducing agent. When aldehydes are reduced, they give the primary alcohols, and ketones on reduction, they give the secondary alcohols. See this example carefully. Ethanol means the common name is acetaldehyde plus H2. Reduction takes place by using ranitidine nickel, or you can use here NaBH4 or lithium aluminum hydride. We get CH3. We get here CH3, CH2OH. This is primary alcohol, and this is a ketone. The common name is acetone, and the IUPAC name is propanone. Again, reduction with nickel or platinum or palladium, they give the secondary alcohols here, CH3, CH3, and OH. So these are the examples. By using, we can prepare the alcohols by using reduction of aldehydes and ketones. Aldehydes, we get the primary alcohol, and from ketones on reduction, we get the secondary alcohols. Remember these two things. Now, by reduction of carboxylic acids, see RCOH, this is the functional group of carboxylic acid. The best reducing agent used is lithium aluminum hydride, LiAlH4. This is a very expensive actually. See in example, it is given acetic acid, CH3COH. It is also called as methanoic acid. The common name is methanoic acid. Lithium aluminum hydride, we get CH3CH2OH. Lithium aluminum hydride is a very good reducing agent which is having capacity to reduce the CO carbonyl group into CH2. See here in this example, CO is converted into CH2 and we get ethyl alcohol. As I explained, the lithium aluminum hydride is an expensive reagent. Therefore, commercially acids are first transferred into esters. See, one example is given in RCOH plus alcohol. We get esters first, and esters on reduction with nickel platinum or nickel palladium, they gives alcohols, mixture of alcohols. They gives mixture of alcohol. So first remember, when carboxylic acids we have to prepare. Commercially, acids are first transferred into esters. Esters are prepared first. So in this reaction, lithium aluminum hydride is not used. So commercially, carboxylic acids first transferred into esters, and esters on reduction, they give alcohols. Then the next method of preparation of alcohols is by using Grignard reagent. Remember, I want to inform you, Grignard reagent, it is prepared by the scientist Victor Grignard. We already learn about this Grignard reagent in halogen derivatives, chapter number 10. It is organometallic compound having prepared with magnesium metal, RMgX. Here, RMgX, Mg having 2 delta plus and X having delta minus, R having, this is the one general reaction it is given here. I will explain the general reactions. Then at your home, you can solve the many examples. CO group, it is carbonyl group. It may be aldehyde or it may be ketone. See, this R having the delta minus char, it will attach to this carbon. It will attach to this carbon. So this bond will be broken. This bond will be broken and we get, just 1 minute. Yes. If this R attacks to this carbonyl carbon, the negative charge will appear on the O minus, and this remaining MgX will be attached here, and we get the intermediate. The intermediate easily gets hydrolysis, and we get the product alcohol here. It is a very simple method. This O minus remains as it is, and after this hydrolysis, H2O, from this H2O, H is attached here, and OH is attached to this MgX and this OH. This OH comes from water, MgXOH. So we can prepare the primary alcohol, you can prepare the secondary alcohol, you can prepare the tertiary alcohol if the aldehyde and ketones are changed. See in the first example here, some examples are given below. HCHO, this is a formaldehyde. RCHO, this is a acetaldehyde, and RCOR, this is ketone. So I want to clarify one thing. If you have used here formaldehyde, you get here primary alcohol. If you use here acetaldehyde, you get the secondary alcohol. And if you use ketone here, we get the tertiary alcohols. So we can prepare the primary alcohols, secondary alcohols, tertiary alcohols by using Grignard reagent. Remember, this is a very important, very important method. Make a star there in your textbook also. This is asked for 2 marks. Mechanism is not required at the time of board exam. Only you can directly write the reaction. It is not expected to show these arrows. For the understanding purpose, it is shown how this alkyl group attacks to this carbonyl and adduct is formed. So at the time of board exam, this is not expected. But if some students understand, they can show the arrows also. Then the next one is preparation of phenols. Now the methods of alcohols are completed. Now the methods of phenols. First one is by using chlorobenzene, Dow process. Dow is the name of the scientist who prepared the phenol by using chlorobenzene. First one, chlorobenzene is first treated with NaOH at the temperature 623 Kelvin and the atmosphere 30 atmospheric pressure is given. First sodium phenoxide is formed, and this sodium phenoxide, after treated with HCl, we get the phenol. So chlorobenzene plus NaOH. First we get the sodium phenoxide here, O minus and Na plus, it is called as sodium phenoxide. And after treatment with dilute HCl, we get here OH minus. This is asked for 1 mark. How will you prepare phenol? By using Dow process. Remember the conditions also. 623 and 30 atmosphere, we have to remember. In your textbook, there is a mistake. Instead of this 30 atmosphere, 300 atmosphere, 150 atmosphere is written. So make a correction in your textbook there. Then second method is, second one is by using cumene. Cumene is nothing but isopropyl benzene. See the structure, then you will understand. This is isopropyl. Why it is called as iso? Because the second carbon having the CH3 group is attached here. This is a carbon number 1. See, sorry, this is carbon number 1. This is carbon number 2. Second carbon having atom having the CH3 group is attached. That's why it is called as isopropyl. This CH3 is CH3. This entire group is called as isopropyl. Remember, isopropyl, not isopropane. Propyl means one hydrogen is less. This is alkyl. Isopropyl, CH3, and this benzene is attached here. So it is cumene. You can remember any name, cumene or isopropyl benzene, it is one and the same. So this is a commercial method for preparation of phenols in industries. This method is used for the preparation of phenols. So it is very simple method and it is very easy. See, cumene is first treated with oxygen. Air oxidation, it is called as air oxidation, O2, in presence of cobalt naphthalate. It is used as a catalyst here, and the temperature is 423. If you remember the temperature, you can write, or if you forgot the temperature, leave it. But don't write the wrong temperature, you will lose your marks. So cobalt naphthalate, if you remember the name of the catalyst, you can write, otherwise leave it. Only air oxidation is sufficient. So cumene with air oxidation, they use cumene hydroperoxide here. See, hydroperoxide means 2 oxygens are bonded together. It is cumene hydroperoxide. O2 is added here. Hydroperoxide is formed. After this cumene hydroperoxide, if it is treated with dilute HCl, we get the phenol here. And the byproduct is acetone. Remember, the byproduct is acetone, which is also useful. It is a very valuable product. We can use for acetone for further reactions. So this is a commercial method used for preparation of phenols. Then the third method is from benzene sulfonic acid. This is benzene sulfonic acid. This is benzene and SO3H group is attached here. So it is called as benzene sulfonic acid. First, it is treated with NaOH. We get sodium benzene sulfonate. This is asked for 3 marks, remember, because this is quite bigger reaction, 2-step reaction. This is asked for 3 marks. For board exam also it is asked. So benzene sulfonic acid. This is acid and base. See here, benzene sulfonic acid is acid and NaOH is added. So the neutralized product is formed. Benzene, sodium benzene sulfonate, it is salt is prepared first. So this is the salt. The name of the salt is sodium benzene sulfonate, SO3 minus and 10A plus. This is salt is prepared. Again, it is treated with NaOH. We get sodium phenoxide, and sodium phenoxide to phenol. You know, this is again Dow process. This is the step which is already included in Dow process. Sodium phenoxide, dilute HCl. We get here phenol. So remember, this reaction is asked for 3 marks. Make a note in your textbook also and in your notebook also. Then from aniline, so when NH2 group is attached to the benzene, it is called as aniline. Remember, when SO3H group is attached to benzene, it is called as benzene sulfonic acid. I request you all, student, please make a practice of these reactions daily, because this is organic chemistry. It is volatile. Only practice is required for this. Don't read the reactions, make a practice to write. At least write each reaction for 2 times or 3 times. Then it will be very easy to remember what is meant by aniline, what is meant by benzene sulfonic acid, what is sodium benzene sulfonate. Though the names are quite difficult, it will be easy when you make a practice of it. So aniline, when it is treated with HNO2, remember this HNO2 is nitrous acid here. It cannot be stored in a bottle. It is prepared in situ. In situ means when NaNO2 is sodium nitrate, see NaNO2 plus HCl is added, we get HNO2. HNO2 is prepared at that instant when reaction is carried out. So HNO2 can be written, or NaNO2 and HCl can be written. The temperature is very low, 223 means it is 0 degrees. This reaction is carried out. At a 0 degree temperature, this reaction is carried out. We get benzene diazonium salt. This benzene diazonium salt or benzene diazonium chloride, it is a very important compound. By this benzene diazonium chloride, you can prepare 7 to 8 different products. In the chapter number 13, amines, we will see in detail how many products are formed. So this benzene diazonium chloride is the intermediate. If it is treated with H2O, means hydrolysis is carried out, we get the phenol plus N2 gas is liberated and HCl is formed. So this reaction, again, it will be repeated in chapter number 13, remember. Aniline, benzene diazonium nitrous acid, benzene diazonium chloride, hydrolysis, we get phenol. If this benzene diazonium chloride is treated with CuBr2, we get chlorobenzene. If it is treated with CuBr2, we get bromobenzene. These reactions will be included in the chapter number 13, the reactions of benzene diazonium chloride. So the method of preparation is completed. Now the physical properties of alcohols and phenols I will take very fast, because these are not asked for exams many times. Nature of intermolecular forces, alcohols, phenols are polar molecules. See, these are polar molecules due to presence of OH bonds. See, this is alcohol, ROH. This is ROH, this is ROH. This is intermolecular hydrogen bonding is there. So the polar groups are held together with intermolecular hydrogen bondings. These are namely called as hydrogen bonds. So intermolecular forces present in alcohol phenols, remember, these are called as hydrogen bonds. Then the physical state of the alcohols and phenols, it is given. Lower alcohols are colorless, toxic liquids. Remember, these are the toxic liquids. Toxic means these are very poisonous, having the characteristics odor. Alcohol having the specific odor. Pure phenol is colorless. If any impurity is there, it becomes colorful. So it is very good test to identify the pure phenols are always colorless. These are also very toxic, remember. These are irritating, having the specific type of smell. Then these are also called as carbolic acids. Remember, phenols having also called as carbolic acids. These are weakly acidic in nature. So many times this is not asked for exam. Boiling points, the boiling points of alcohol phenols increases with increase in molecular mass. And you know one important property of boiling points. Boiling points decreases when the branching increases. I will show one table to you after this solubility. Phenols and lower alcohols up to the 3 carbons. They shows appreciable solubility in water due to the ability to form the intermolecular hydrogen bonding with water molecules. See in this example, I will show. This is hydrogen bonds. Hydrogen's bonds are formed with alcohol. This is ROH. See, this is ROH, ROH. This is alcohol, and this is water. So the intermolecular hydrogen bond is formed between oxygen and hydrogen. This oxygen, this hydrogen. Again, in case of phenol, see, this is AROH. This is AR, benzene ring, OH. This is OH, and the bonds are formed here. See, this is water molecule, and these bonds are called, these are called as intermolecular hydrogen bonding. Due to this intermolecular hydrogen bonding, these are quite soluble in water. Now come to this chart. Actually, no any question will be asked on this chart because all these are contains values. No any question will be asked for board exam on the values. Remember, means you didn't require to remember these values, but the question will be asked why the melting point decreases when the branching increases. See this, I will take one example here. See the N-butyl alcohol. See, N-butyl alcohol having the boiling point is 118. Then isobutyl alcohol having the boiling point 108. The secondary butyl alcohol is a boiling point having 99.5, and the tertiary butyl alcohol having the boiling point 83. So on this, the question will be asked for board exam. Why the N-butyl alcohol is having the highest boiling point? The simple answer of this question is it is a straight chain. It doesn't having the branching. As the branching increases, see the boiling point is decreases. So it will be asked for 1 mark or 2 mark. Remember, N-butyl alcohol is having the 118 because it is straight chain, do not having the branching. If the branching increases, see the boiling point decreases. So this question is a problem is depend on this. Just I explained this problem. Exercise are given to you. You can solve this exercise at your home. Now the chemical properties of alcohols and phenol, how these reacts. In our laboratory, we can test the phenols and alcohols. This is a distinguishing test between alcohols and phenols. Remember, this is very important. This is asked for 1 mark. Characteristics test for phenols and alcohols. Phenols react with a neutral ferric chloride, FeCl3. FeCl3 is a ferric chloride. It gives a deep color. Deep color, it may be purple color, violet color, or green colored ferric phenoxide. This test is given only by phenols. This test do not given by the alcohol, so we can easily identify the alcohols and phenols. Phenols gives generally violet color and green color. This is called the deep color. This is due to the ferric phenoxide. This is a ferric phenoxide. Remember, ARO thrice Fe. This is ferric phenoxide. Remember. Then next one is a distinguishing test for alcohols. We can identify the tertiary alcohols, secondary alcohols, and primary alcohols by using Lucas test. This Lucas word many times you ask, many times you heard in the chapter halogen derivatives. Lucas reagent means this reagent with HCl, concentrated HCl, and ZnCl2. This combination is called as Lucas reagent. So again, this Lucas reagent we are using for this test. This is ROH is alcohol, HCl, ZnSO is a Lucas reagent, and you get here RCl. This is alkyl chloride. Now, how will you distinguish the primary alcohols, secondary alcohols, and tertiary alcohols? I will explain. Alcohols are soluble in Lucas reagent, remember, but the product is not soluble. This alcohols are soluble in the Lucas reagent, but the product is not soluble. This alkyl chloride is not soluble in Lucas reagent. Hence, the clear solution becomes turbid when the product starts forming. So if this alcohol is dissolved in Lucas reagent, the clear solution is obtained first. And as the product appears, the solution becomes turbid, means it becomes white. So according to this, we can easily identify the tertiary alcohols, secondary alcohols, and primary alcohols. How the tertiary alcohols are identified? Tertiary alcohols reacts fast, very fast, and the reagent turns turbid very fast, instantaneously, immediately. When alcohol is added, immediately the solution becomes turbid, so easily we can identify the tertiary alcohols are used. Then if secondary alcohols are used, they turn the reagent turbid slowly. Means if the secondary alcohols are used, the turbidity appears slowly, and if the primary alcohols are used, we will get the turbidity when the solution is heated. So primary alcohols react very slowly, the tertiary alcohols react very fastly, and the secondary alcohols react in between tertiary and primary alcohols. So with the help of the turbidity of the solution, we can easily identify which alcohol is used. So this is a distinguishing test for alcohols. Make a star there. It is also important for exam. Newly it is introduced in the syllabus. In 2012 syllabus, this test is not there. Newly it is introduced in this new syllabus. Then next one, reaction due to the breaking of OH bond. So I will explain here. Alcohols, when it is in aqueous condition, they give alkoxides. See, alcohols plus water, they give alkoxides plus H3O plus. Now, R group doesn't having any resonance structure here. See, R group doesn't having any resonance structure because this is a electron donating effect. It shows electron donating effect. R group is electron donating inductive effect. I effect plus I effect. Due to this plus I effect, this alkoxide group become destabilized. This is a conjugate base of alcohol. As a result, it does not ionize much in water, so it becomes neutral. Alcohols are neutral and phenols are acidic. Only the 10 minutes are remaining. So I will take fast. So remember, when alcohols are in aqueous medium, they act as alkoxide. These alkoxides are destabilized due to the plus R effect of this R alcohol plus R electron donating effect. So it becomes destabilized. Now, what is the difference between alcohols and phenols? See, in case of phenols, if the phenols are in aqueous condition, they form the sodium phenoxide. Alcohols form alkoxides and phenols form phenoxides. So I will explain the difference between phenoxides and alcohols. See carefully here. This is when phenols are treated with water, they forms phenoxides. See, this is O minus is phenoxide, but this phenoxide is stabilized due to resonance. See, this phenoxide, it is stabilized due to the resonance effect. It is stabilized by the resonance effect. You can see the structure 1, 2, 3, 4, 5. In all the 5 structures, this phenoxide, this is a conjugate base of the phenol. It is stabilized due to the resonance. But in case of this alkoxide, see, this is a conjugate base of alcohol. It is not stabilized because there is no any benzene ring is attached here. R group is there. It is a destabilized. Electron donating effect destabilizes and electron withdrawing effect stabilizes. See, in case of phenoxide ion, the conjugate base of phenol is stabilized due to the resonance. Resonance is nothing but delocalization of electrons. In 11th standard in chapter number 15, aromatic compounds, we learn about this resonance. Resonance is nothing but only the negative charge is rotated here. See 1, 2, 3, 4, 5. Only the negative charge is rotated and it is stabilized. So the phenol ionizes in aqueous medium in some extent. So there is a weakly acidic, and alcohols do not ionizes. See, this is a difference between alcohols and phenols. Alcohols do not ionizes because this is destabilized. Which one? Alkoxide is destabilized due to resonance, and the phenoxides are stabilized. See the difference between stability and destability. Alkoxides are destabilized because there is no resonance, but the phenoxides are stabilized due to the resonance because of this benzene ring. Now this one problem is given. You can solve at your home. This is a depend upon the stabilization and destabilization. Esterification reaction I want to explain now. Esters are the functional groups. Alcohols and phenols form esters when they react with carboxylic acids, then acid halides and acid anhydrides. Esterification is the reaction. I will explain the definition. The reaction between alcohol phenols with carboxylic acids. Alcohols, phenols treated with carboxylic acid, esters are formed. This is, see this example. With the help of example, clearly we can understand what is, this is alcohol and this is phenol. See ROH, AROH. Acid, this is carboxylic acid. RCOH, this is also RCOH. In acidic condition, we get esters here. In both the reaction, we get ester. This oxygen having the lone pair of electron, it attacks on this carbonyl, and we get this OH minus is removed. This OH minus combines with this H, we get H2O. If anybody wants the mechanism, I will explain the mechanism. Please call me. But for the 12th standard exam, the mechanism is not required for the board exam. Those students who are preparing for NEET and JEE, they required the mechanism, because for the understanding purpose, the mechanism is very important. So with this reaction, alcohols when treated with acids, they give esters. Phenols are treated with acid, they give. This is nothing but esterification reactions, remember. Then esters can be prepared by using anhydride also. Ester can be prepared by using acid chloride also. Means we can prepare the esters by using carboxylic acids. We can prepare the esters by using anhydrides. You can prepare the esters by using acid chloride. Different reactions are given here. Alcohol plus anhydride, again ester is given. Ester plus acetic acid. So the mechanism is important here. This ROH, this oxygen attacks here, and this group entire is removed, RCOO. RCOO combines with this hydrogen and we get the carboxylic acid is a byproduct. In this reaction, RCOO and this H is combined, we get the, RCOO, this is combined with this R, H is removed, and this OH, it combines, we get the H2O. In this RCOO and this H, it is removed, we get the carboxylic acid here. In this reaction is also same. This oxygen attacks here, we get the Cl combines with hydrogen and HCl is formed. So make a practice at your home. Then acetyl derivatives. See, this is salicylic acid. Directly I am coming to the what is meant by acetyl group. Acetyl group means CH3CO group. This CH3CO group is prepared by using alcohols and phenols. जितने OH groups है, उतने acetyl group prepare होंगे reaction में. Remember, see in this salicylic acid, one OH group is there. One OH group is there at ortho position. This OH, and this is a acetic anhydride. This oxygen attacks to this carbonyl, and this entire group is removed, CH3COO, and we get there acetyl group at the ortho position, and acetic acid is a byproduct. This is aspirin drug. Aspirin is a well-known generic medicine. It is used as a antipyretic. Aspirin. Remember, it is asked for 1 mark for the exam. Very, very important, make a star there. How the aspirin is prepared. So aspirin is prepared by using salicylic acid and acetic anhydride. We get the acetyl group here, acetyl group, CH3CO group, CH3CO group. जितने OH groups होंगे उतना acetyl groups prepare होंगे reaction में. Remember, this is a very important thing in this reaction. So these are called as acetyl derivatives. Then these reactions, all these reactions are completed in halogen derivative. Just within 1 minute, I will explain all this reaction with hydrogen halides. These are completed in halogen derivatives. Alcohols, when treated with HX, this group is replaced. OH is replaced with X. This is the Lucas reagent. All these reactions are many times, these are repeated in halogen derivatives. Ethyl alcohol plus HCl, ZnCl2. This OH is replaced with chlorine and we get here ethyl chloride. Then for the bromination, HBr is added. HBr is prepared in situ by using this NABr and H2SO4. These all the reactions are completed in halogen derivatives, and HI, it is also prepared in situ by using sodium iodide and H2SO4. In situ matlab these are not stored in bottle actually. These are prepared at that instant. Like HCl, we can prepare in bottle, we can directly use, but the HBr and HI we can't use directly because these are prepared in situ by using these reagents. Then reaction with phosphorus halides by using phosphorus trichloride, then penthalide, then Lucas reagent. All these reactions are completed in halogen derivatives. See, these examples are completed. Same reactions I have taken from these halogen derivatives. I think you remember the chart. I will explain this chart within 1 minute. So 1 minute is only remaining. So ROH, alcohol plus Lucas reagent, we get here RCl. Then NABR H2SO4, we get RBr. PX3, this is PCl3, we get R3RX. PCl5, we get POCl3 is a byproduct. Then this is a PX2, this is a PBr3 and PI3. We get alkyl halides, and this is last reaction is SOCl2. This is thionyl chloride. See the last one. This one SOCl2. You see, it is also called as sulfonyl chloride. It is also called as thionyl chloride. It is also called as the Darzan's process. We get the RCl and two gases are removed here. So all these reactions are from the halogen derivatives. This is the 11th standard reaction. Dehydration of alcohols. I will explain this reaction and we will stop here. Dehydration means, you know, D ka matlab, D means we have to remove, hydration means H2O molecule is removed.